Welcome everyone. In this video I'm trying to explain you how to communicate with an Arduino. So how to send some data, for example different commands, and how to receive some data from the Arduino. And I'm planning to do a series of videos about this. So in this video, in the first video, I will show you the basics, and then I will build on this video and expand the possible things that we can do with Arduino. So for example, in this video I just show you the very basics to send and receive data using the Arduino software's internal serial terminal. And then in the next video I'm going to write Windows software using Microsoft Visual Studio and C# language, and I will make my own terminal and I will send and receive data with my own software. And in the third part I will make something which is very interesting for a lot of people, and some of you asked for it. So I will make software which is able to receive data from the Arduino and which is able to visualize the data on a chart. So for example, we read the temperature using a digital temperature sensor which is connected to the Arduino, and we send the temperature data in each second, let's say. Then we will catch those data which is coming through the serial port. We catch those data with our own software on the computer, and then we will visualize this data on a chart, and also we will be able to save it into a text file. So, and then if I show you these basic things and you understand them properly, you will be able to expand these basic software and you will be able to write your own software. So let's start with this code. So as I said, I will show you some very basic things. So what I do here, I have two Boolean variables, and those are set to false as default. I will have two strings, scene1 and scene2. Scene is like serial input, it doesn't matter. We have two numbers. We have one character defined, and that's the received command. And I just need to count the cycles, so I made a variable for that. So it's very simple. And then we have the setup part. So of course we initialize the serial communication, and then I just print some stuff. What I did here, I made some things that I want to show you, and I made some abbreviations and a short description of these abbreviations. So we will see these things when we start the Arduino. And then I kept the loop very simple. I just put in three functions. These check serial switch case and check serial if or if. They are the same, but they are implemented in different ways. Some people say that if you have a lot of if statements, then it's better to use the switch case statements. So I implemented both, and you can decide which is better for you. And then send formatted data is just a function which can be started and stopped through the serial port. So I will show you how to work with it. So first, as you can see, I commented out this part here. So we will use the check serial if function first. So I show you how it works, and you can see if it's suitable for your needs or not. So first of all, we see this part of this big function. So we step in this function, and the first thing that the software meets, that check if there is anything on the serial, and then if there is something, then we read it, and we have to know what we send, so we have to design this for our needs. I will just send one simple character. So in this case we read one simple character and we put it in the variable received command, and we also say that the we also set the new data variable, which is a boolean variable. We set it to true, and then if that is true, then we step in this new part, a new if statement. So if new data is true, then we check what is the received command, and then we can see if it was the character M, then we read another character. It's or not a character, a string, sorry. So we can print in, we can write in anything, and then we just create a message, like the message was something, and we send back the same. So we read a string with the Arduino from the serial port, we put it in a variable, and then we just send it back to the computer. That's all. That's why it's mirror. So it sends back the same. Or if the received command was A, which is addition, so in this case we have to define two numbers. So the command will look like something like this. So A, and you put the space, and then you write your first number, another space here, and then the second number, and then hit enter. And then what this part will do is it receives the A, so it steps in this part, and then it reads the first number, puts it in the num1 variable, and reads the second number and puts it in num2. And then we have a function called add two numbers, num1, num2, that is like this is given to the function. So if we go down, here we have our add two numbers. So we have two floats, or whatever you decide to choose. So we create a variable, we store the result in that, and we just add the two numbers and assign this value to the result, and then we just write our regular message. The result is, and then we print the result, and that's all. So far it's quite simple. And then we can have another function with this. So if we send a character C, we also expect a number. So the command could be, let's say, C space 5, which means that we read this number, put it in num1, and then we use this counter code function, which does the following. So we are here in this part. So we receive this number, which is coming from here, and then we step in this for loop, and until we don't reach that number, sorry, this should be num1, and this is also, so until we reach the number. So if it was 5, then we count until 5 and delay it every 1 second. So we print, we wait a second when we enter this for loop, and then we print a number, and we start from 1, so 0 plus 1, so we start from 1, and then we just write this much seconds elapsed. And then we do again, and then 2 seconds, 3 seconds, whatever, and then it's 5. If num1 was 5, then we are finished. We print another message just to make sure that it's done, and we just escape this part. So it's quite simple. And then there's another code here. I called it D, like data. So here, simple, and then I think this is a very funny and very smart stuff to do. We just change the value of a Boolean variable. So we make this enable run true. And why? If you remember, in this send in the loop, we have this send formatted data function. So if we check that function, this part here, it is always waiting for the enable run variable to become true. So as long as this is false, then the loop skips over this and only tries to check whether there is a data in the if or not. So it, oversimplifying the things, it peeks into this, and it sees that the enable data is false, and then it just moves along and goes back to this part. So it does until you don't change the value of it into true, and when it's true, then we print a message. One will contain the variable cycles, and then we put a tab, and then we print the running time of the CPU, and then another tab, and we just multiply the CPU with a random number. I just chose 3, and then we just print a new line. So the final result will be formatted in a nice way, and this should be the expected results, one of the expected results, not necessarily with these numbers, but it will look like this. So this is the cycles, and then we have the millis, and then we have the millis times 3, and then we wait 1 second here, we increase the number, increase the value of the cycles, and then we go back until the enable run does not become false. So this is the code, and how this comes false once we switched it to true. Well, if we go back to this part, so we left here, there is another that controls this part. This should be code, not motor. So when we reach this part and we send a character S, then this enable run equals false will be enable run will be switched to false, and then we also write a message like stopped, just to make sure. And then if we finish this new data equals true, then we switch it back to false, because otherwise if we leave it true, then this will cause like a infinite loop with all these things within this statement, and then it will always see that oh, this variable is, let's say, C, and then it will infinitely do or execute this function. So this is it, and we can do this same with the switch case. So I just show you one example, and then you will be able to download the code and see how it works. But again, we have this serial available part in the switch case, and then again we read the command character here. Here it was received command, it doesn't matter, but here we call it command character. So we read a character, and then we create this switch command character, and then we see what comes to this place. So for example, if the switch was M, so the case is M, then we do the mirror stuff. So we read a string, put it in this scene1 variable, and then we print it back, and then we are done. It's the same as we close down the if statement. Again, if we want to add two numbers, then we read the two numbers here, and we put them in the function, and then the function will do the operation and return back with the number. C, not S, but C, and count. I modified some older code, that's why some parts are funny when you read them. But the uploaded code will be clear and will not have any errors. So if we have the C, we count, so we get the data, how long we want to count, and then we execute that part. And then D, we get the formatted data, and then we stop getting the formatted data, and that's all. So now I show you how it works with the if. So if you see, the switch case is commented out, so we will go through with the if. So we start the serial, and then we get back these messages, which are here, you can see. So mirror, so we press M and we write mirror, and then I press enter, and then the message was mirror, or M123 ABCD, and then we get back the same message. So this was quite obvious. We had this part, and then we can add two numbers. So as the example said, A42-1. The result is 43. Yeah, it can do the math. We can do other numbers. 11 plus 22. This should be 33. Yeah, it works. So this part is cleared. So now we count until 5. 1, 2, 3, 4, 5, and done. So counting is done, and now we want to get a data. So we just start with by sending the command D. So you see the first column under the word done, that is the cycles. The second is the millis, and then the third is 3 times the millis. So the second column is just the CPU's running time in millisecond. So after you restart your Arduino, an internal timer starts, and you see the number of that. And now we want to stop this. So I send the letter S as it is shown here. So that will switch the enable run flag or variable to false. So let's send the S letter. Stopped, and we stopped receive data. So to continue with the next video, which I will upload separately, I think this last command is the most important, because if you want to generate some data, for example, you want to create a small weather station, you want to measure time with a real-time clock, or you want to measure something as a function of time, then this is the most important thing that you should do. So you have to format your data. So as we do it here in this part, then you can see that we have the serial print parentheses cycles, and then we have it here 0, 1, 2, and so on and so on. And then we make a tabulation here, so there is a tab between 0 and the second number, so that's there. And then we write out the second number in the second column, which is the millis, and then another tab, and then another number, and you can continue this basically infinitely. Of course you will suffer because of the speed, but that's all. And also you can do like, you can make a string out of the several numbers and just send it by one serial.print command, which can speed up maybe, but I honestly don't know which process is quicker. If you send it like this, so you basically have to send 6 serial.print commands, or you have to merge the different variables into a string and just send the string by one command. We can make a test for that later, but I think this is the most important, because once you have this, either you save this straight to a text file and then you process it with your favorite processor, which can be GNU Plot or Origin or Excel or whatever, or you can write your own program, as we will do it, and you can process these lines and make them into variables, and make them into values or variables, and use them. So for example, with this we will see that we can separate these numbers based on the tab, and then we can put them into arrays, for example, and later we can plot the numbers from the arrays on a graph and see what happens, and we can do this in real time. So this was the video. I hope you learned something, and in the next video we will write our own software in Visual Studio and do the same stuff as what I showed here, but with our own serial terminal. So see you in the next video, and I hope that this was useful for you. So see you.